All right, let's jump right in. If you're studying for that PMMI Industrial Electricity 1 exam, you know the three-phase motor is a big deal. But honestly, even if you're not, these things are everywhere. They're in pretty much any factory you walk into. So let's crack the code on how they actually work.
And I'm not kidding when I say they're common. These things are the absolute workhorses of the modern world. I mean, they're powering everything. The conveyors moving products, the pumps pushing fluids around, the compressors giving us air. They're kind of like the invisible muscle that makes all of industry move.
So you see the big metal case, you hear it humming away, but what is the magic happening inside? How does it take electricity and turn it into this incredibly powerful, spinning force? Well, that's exactly what we're going to break down.
So over the next few minutes, we're going to peel back the layers on this unsung hero. We'll get into how they work, how you start them up, and the key secrets you absolutely have to know to master them.
So why does all of industry run on three-phase power? Well, it really boils down to three huge advantages. First, they're just way more efficient. You get the same power with less current. Second, the power delivery is super smooth and constant. And third, for the same amount of horsepower, the motor itself is smaller and lighter. I mean, it's a total win-win-win. Okay, let's get to the really cool part. How does this thing actually spin? How do you get rotation from just electricity and wires? It's all about two key components and the invisible force they create together. First, you've got the stator. And the key word here is stationary. This part doesn't move, it just sits there. Inside, it has three different sets of coiled wires, or windings. When you hit it with that three-phase power, those windings create this incredible rotating magnetic field inside the motor. And get this field is the real engine here, and it's created with absolutely no moving parts. How cool is that? So, what's that spinning magnetic field doing? It's pulling on the rotor. The rotor is the part that, actually rotates. The most common kind is called a squirrel-cage rotor, and it's brilliantly simple. No brushes, no wires connected to it. It's just a chunk of metal designed to be grabbed by that magnetic field. It's basically like a dog chasing its tail. It just follows that field around and around, and that's what creates the torque to spin the shaft.
So let's just recap that real quick to make sure it sticks. The stator, it creates the magnetic field and it stays put. The rotor, it follows that field and it's the part that spins. It's a really elegant partnership between two very different parts.
Okay, so we know how it works in theory, but how do we actually use one? For that, you got to learn to read its ID tag. Think of the nameplate as the motor's passport and its instruction manual, all rolled into one. Literally, all the critical info you need is right here. You've got the voltage, the amps it pulls when it's working hard, its horsepower, all of it. And you've got to pay attention, because misreading this is a super fast way to get an exam question wrong, or, way worse, fry a motor in the real world.
And here's the bottom line. The nameplate is king. It's the final authority, period. You'll see dual voltage motors, right? Like 230/460 volts. It can run on either voltage, but you have to connect the wires differently depending on which one you use. The diagram on the nameplate shows you exactly how. And don't forget, lower voltage means higher amps. You absolutely have to get that right.
All right, let's talk about firing this thing up. The most common way, by far, is called across-the-line starting. It's super simple, but you need to brace yourself, because it creates a pretty big electrical jolt when it kicks on.
So what's across the line mean? Well, it's pretty much what it sounds like. You push the start button, a big switch called a contactor slams shut, and boom, the motor gets the full blast of line voltage all at once. There's no easing into it, no gentle start. It's just 0 to full speed right now.
And what's the catch with that instant power-up? Well, for just a split second, the motor gulps down a huge surge of current. We're talking 5 to 7 times its normal running amps. We call that inrush current. Now, it's totally normal, but it's the biggest drawback to this starting method, and it totally changes how we have to protect the whole system.
And this brings us to something that trips up so many people, especially on exams. You need two totally separate protection systems. Think of it like this. The overload relay is the motor's personal bodyguard. It protects the motor from working too hard for too long. But the fuse or circuit breaker, that's security for the whole building. It protects the wires from a major disaster like a short circuit. They have different jobs, and you need both. No exceptions.
Okay, time for a quick lightning round. Let's nail down the absolute must-knows for the exam. You're going to want to remember these. First up, how do you reverse the motor's direction? It couldn't be easier. You find your 3 power lines coming in, L1, L2, and L3. Then, just swap any 2 of them. Doesn't matter which 2. That's it. The motor will spin the other way. Seriously, that's it. Must know number 1, swap 2 leads, and you reverse the rotation. I guarantee you'll see this one again.
Must know number 2. The nameplate is law. Always, always, always double-check your supply voltage and your wiring against what that nameplate says.
And must know number 3, overloads are not fuses. Remember, the overload is the motor's bodyguard. The fuse or breaker is security for the circuit. 2 different jobs, both are required.
So there it is. You've cracked the code on the workhorse of industry. The ideas behind it are actually pretty simple, but they're incredibly powerful. And hey, next time you're walking around a plant and you see a control panel, peek inside. I bet you'll be able to spot the contactors, the overload relays, and those 3 wires heading out to a motor. Because now that you know the code, you're going to start seeing it everywhere.